Okay, let's dive right into this. Welcome, everyone. I want you to imagine, just for a second, stepping onto a football pitch. Now, imagine walking out there without knowing your formation, having absolutely zero tactics in mind, and with no clue how you're going to outplay the opponent's defense. You wouldn't do it, right? It would be a guaranteed loss. Yet, literally thousands of students walk into their Cambridge computer science exams, and I'm talking whether you're sitting for the 0417, the 0478, the 2210, or even the advanced 9618 syllabus, doing exactly that. They walk in without a game plan. Well, today I am playing the role of your strategist. We are going to completely transform basic binary and denary memorization. We're taking it from a super dry, boring list of ones and zeros, and we are turning it into a hardcore tactical playbook for scoring absolute top marks. Our core concept for this entire masterclass is formation, tactics, and execution. Because today, we are going to outplay the ultimate defense, those incredibly tricky question barriers set up by the Cambridge examiners.
So here is our roadmap for today's strategy session. Think of this as your complete playbook covering both offense and defense. First up, we're tackling what I call the context trap. Then we'll shift gears into our offensive strategy with the 4-step exam method. After that, we look at training with the 3-pass revision cycle, play some defense with common pitfalls to avoid, and finally, we will lock it all in with your final exam checklist. Let's get moving.
All right, Section 1, the context trap, escaping isolated facts. We have to start with the single biggest hurdle students face. To really understand this trap, I want to show you a real Cambridge computer science past paper scenario. Let's look at two totally different students, Alex and Sam. Now, Alex is what I call the classic overloader. When Alex gets a question asking about binary in a specific embedded system, Alex just panics and dumps raw computer science facts onto the page. There is zero analysis. It's just binary is base 2, it uses ones and zeros, and that's it. Then we have our second student, Sam. Sam is moving way too fast. Sam rushes the question, completely misses the critical command word, which happens to be evaluate, and instead of evaluating just lists a very basic textbook definition. So what happens? Both of these students end up with an exam paper that is just bleeding with red pen marks. Why? Because they learned binary and denary as completely isolated facts rather than functional concepts connected to a real system.
So I really want to pose this critical problem to you. Think about this. Why do students who know the theory perfectly well still lose marks? I mean, both Alex and Sam know what binary is. They've memorized the flashcards. But here is the brutal truth of the Cambridge exams. Memorized terminology is absolutely 100% useless if you do not know what digital problem it actually solves or what specific hardware device is involved in the exact scenario you've been given. A strong, top-tier answer always begins with the realistic problem presented on the paper. The examiners aren't just testing your memory. They don't care if you can act like a dictionary. They are aggressively testing your ability to move from basic recognition to deep understanding to real-world application. The difference between an isolated definition and a high-scoring, context-anchored explanation is honestly night and day. Take a look at this comparison. On the left side, we have Alex's highly generic answer. It says, binary uses ones and zeros. Computers use it for data. That gets exactly 0 method marks. None. But on the right side, look at this green check answer. The knowledge is applied specifically to a robotics scenario, detailing exactly why binary is used. It says, in the factory robotics system, binary is used by the sensors to send discrete on-off signals to the microprocessor, ensuring immediate processing of safety protocols. Do you see the difference? It mentions the factory robotics system. It talks about discrete on-off signals. It explicitly names the microprocessor, and it gives the ultimate reason, immediate processing of safety protocols. That is how you unlock full marks. And I am going to show you exactly how you can consistently generate that brilliant answer on the right. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2, the 4-step exam method. Securing your method marks. This right here brings us to our offensive strategy. If you actually want to secure those method marks, you can't just guess. You need a highly disciplined technical methodology to build a perfect answer from scratch. This is where we introduce a total game changer, the PEAL framework. That stands for point, evidence, explanation, link. Top-performing students structure every single one of their computer science answers using this exact formation. First, you have to decode the command word. Is the examiner asking you to describe, to explain, or to evaluate? They all demand completely different types of answers. Then, you apply the Peel framework to build out your response.
Let's break down those 4 essential steps so you can diagnose literally any question they throw at you. Step 1. Identify the exact requirement. You absolutely must decode the command word first. Step 2. Classify the relevant data or hardware. That becomes your point. Step 3. Explain how the technical process works in a highly clear, logical sequence. That is your explanation. Step 4. Connect the entire explanation explicitly back to the scenario. That is your link. This specific framework acts like a guardrail. It prevents you from just writing everything you know about a topic without any clear direction. Imagine if Alex learned to use this method. Those red pen marks would instantly transform into green check marks. Instead of writing binary as ones and zeros, Alex would follow the formula and write, "The embedded system requires binary because the microprocessor relies on logic gates to control the greenhouse temperature based on sensor inputs." That hits the point, the explanation, and the link beautifully.
Section 3. The 3-pass revision cycle. Training for exam adaptability. So we've just seen the amazing transformation in how Alex and Sam could write their answers using the Peel method. But here is the real question. How do you actually bake that level of precision into your brain before test day? You cannot just read your class notes once, highlight a few words in yellow, and expect to perform at an A-star level. It just doesn't work. You need a heavily structured, layered timeline for your revision. You have to train for adaptability.
Now, I really want to highlight this incredible insight. This quote is derived directly from principal examiner warnings. Listen closely to what they are telling us. The same patterns appear in smartphones, websites, school systems, industrial control. Showing these links helps students remember. Real-world transfer is the absolute secret to retaining all of this highly complex information. The underlying mathematical mechanics of binary and denary, they are exactly the same whether you are looking at a smartphone's MAC address, a school network's IP address, or the sensors on an industrial control robot. The ones and zeros behave exactly the same way. By recognizing these universal patterns, you can completely stop memorizing isolated facts and finally start understanding the fundamental rules of the game. Once you see the matrix, you can't unsee it. So here is your highly structured timeline for making that happen. Pass 1 is all about securing definitions and contrasts. What is the fundamental difference between binary and denary? You need that baseline. Pass 2 is rehearsing worked explanations. This means physically writing down and tracing a binary shift step by step until you can do it in your sleep. But Pass 3 is the absolute magic pass. This is where you focus purely on exam adaptability by completely changing the scenario. You take a past paper question about a hospital database, you answer it, and then you force yourself to completely rewrite your answer as if it were a banking security system. What changes? What stays the same? That's how you learn. Stopping at Pass 1 is a mathematically guaranteed way to lose points when the exam scenario inevitably changes on test day. You have to put the reps in. Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Common pitfalls to avoid. The classic wrong turns. Now we have to pivot to the defensive maneuvers of our playbook. We are going to run a rapid-fire, interactive workshop right now, focusing entirely on the hidden traps that frequently catch even the most well-prepared, high-achieving students. These are the classic wrong turns. I want you to imagine a 60-second timer popping up on your screen right now as we run through these challenges. We are testing your ability to spot critical errors right here, right now, before you ever make them in the actual exam hall. For our very first challenge, let's do a quick data scan. Look at the rule on the screen. The golden rule here is that generic responses rarely gain full marks. If the specific context of your exam question is about a local school network or maybe a bespoke embedded system inside a microwave, your answer must stay rigorously and completely inside that specific context. You cannot zoom out to generalities. A massive, grade-destroying trap is naming a device, let's say a MAC address or a network router, without actually explaining how it uses binary or hexadecimal to route data. You absolutely must explain the technical how, not just list the what. If you just name-drop hardware without explaining its process, the examiner cuts your marks immediately. Okay, let's move to Challenge 2, Find the Flaw. I'm going to list out these classic mistakes that completely drain your marks. First, vague wording. It is a total killer. Be precise. Second, confusing similar terms.
A classic example is saying storage when you actually mean memory in the context of binary data retrieval. That single swapped word will cost you heavily. Third, missing steps in a process sequence. Like if you completely skip explaining how a Denary number is converted before it is processed by the arithmetic logic unit, or ALU. You can't just skip to the end result. Fourth, failing to anchor to the context, which we just hammered home in the last challenge. And finally, giving an advantage without providing a solid reason. You cannot just write down, binary is faster for computers. Faster why? You have to explain that it's faster because it maps directly to the two physical states of hardware logic gates, on and off. Recognizing these specific errors is extremely high-yield studying. Now, for challenge 3, speed writing. Imagine a 30-second timer counting down right now. Your ongoing mission is to speed write one perfect PEL paragraph, avoiding every single one of these bullets. Keep that standard in your head at all times.
Section 5, your final exam checklist, the 4 prompts. As we finally bring all of these different tactics together into one cohesive strategy, we reach the ultimate final system. This right here is your ultimate self-test framework. It is a mental checklist that you can easily visualize right before stepping into the exam hall. We've deeply covered command word decoding, we've walked through the PEL framework application, and we've successfully navigated the most common pitfalls. Now, let's look at the specific 4 prompts you need to verify that your knowledge is absolutely exam ready.
Here is exactly how you consolidate everything we've talked about. You need to ask yourself these 4 prompts aloud. First, what is it? Answering that secures your definition marks. Second, how does it work? Answering that secures your technical process sequencing. Third, where is it used? That perfectly anchors you to the specific scenario context. And fourth, why is it better or worse? That prepares you for those high-mark evaluation and alternative-based questions. If you can take literally any topic on the syllabus, whether it's binary addition, MAC addressing, ASCII representation, whatever it is, and answer these 4 prompts aloud, you have successfully rebuilt the topic into an ultra-reliable memory structure. You are 100% ready to walk into that room. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
So, as we wrap up this masterclass, here is my final provocative challenge to you. Can you apply these exact 4 prompts, along with our strategic PEL framework, to the very next past paper you open? I want you to try it tonight. Grab a paper, decode the command words, build your points, and execute. You have the complete playbook now. There are no more excuses. Get out there, start implementing your strategy, and absolutely dominate that exam.